Welcome to session 5 of Hypermesh Radio's interface demos. In this section, I'll be showing how to create, monitor, control volume, and added mass. So I'll be showing demo on these two topics. So let's move on to the model. So in the previous section, we created all the contacts which are required for this model. As a monitor volume, the application in this model is for the tires. So we have modeled the tire using the shell mesh. So we have the shell mesh and we have the gravity load. So if we don't specify the medium which is inside, the pressurized air, then you can assume that it will get flattened. So we have to say inside we have inside we have an air of this much of pressure and all that. So that activity we'll be doing using monitored volume or control volume. So this is the very simple application of monitored volume, but the more detailed or the complex application may be the airbags. So in the airbags, monitored volume is quite a big thing. So we have a lot of options which we use in the monitored volume section for airbags. Anyway, so we don't have that here. So we'll create a monitor volume for the tires. So before we do that, monitor volume, some of the conditions you should understand, which is so if we have to define the monitor volume, then that object should be a closed volume. Okay, now if I check if it is a closed one, so I'll just try to find the edges. Oh, I'm going for deconnections, free edges, fine. So it is telling it is a closed volume. So there are no edges and it's a closed volume. So the first condition is if you want to create a monitored volume, it should be a closed volume. Okay, that is the first condition. And the second condition is the normals have to be facing outward. So let's check that one. So we have tools and normals. So I will check for the elements. I'll go with arrow display so that I can see the vectors properly. So I will just select the elements and I will say display. So I will go close and yeah, they are looking outward. So the other easier option, now I'm ensuring that these elements are like the normal is projecting outward. So now I will check the outward is normally the red. So I have to ensure that all of this is having one color. Yeah, so we saw this was outward and that is showing red. So all the elements should be the same thing. Otherwise, you know the things how we can change the orientation and we can make it outward. Okay. As of now, all is good. So all are facing outward. So these two are the prerequisite from the modeling perspective, how it has to be to create the monitor volume. So that is fine. Now monitor volume, it requires these entities to be called as surface part. So initially I have to create a set and that set I'll be calling it in monitored volume. Okay, now I'm coming to a new browser here, which is a solver browser. So I'm just taking this opportunity also to show you how we can work with the solver browser. Okay, so say that if you are more conversant with the solver options, so you know the cards already, then this is more handy to work. So here, most of the things are alphabetical. See now I just want to create a surface part, so I will go with that alphabetical order. So I will find surfaces. Okay, I have to create surf and I have to create surf part. So directly I'll go to that option. Okay, so now I am creating Okay, so these two are in one, and the other two are is in the different. So let me create two. Okay, so I will select this one. Okay, and I'll name them as rare. Okay, good. So same thing, I will do it. Or I'll just duplicate this and I'll make this one as friend. Okay, so components, I will refresh because I don't want these components to be there in the front also. So I will refresh. See, now we don't have any component. Now I'll pick this component. Okay, fine. Yeah, good. So I think this is taking alphabetical. Yeah, so that's why it has gone there. Okay, fine. So I have created two surface parts, which I'll be now calling it in the modeled volume. So even for this, I'll go with this option. So create modeled volume. And for the application like this, I'll be using gas. For the application of for a tire, I'll be using the gas. Otherwise, for the airbag, you're seeing many other options for the airbags. And the last one, pressure, we also have an option where we can define the pressure rise with respect to pressure rise or pressure drop with respect to time. We can define a function using the last option. But now I'm going with the simplest one, which we use for tires. Okay, so here my first job I will call the set which I have created. Okay, so I will create for the layer. So I'm calling it here. So the parameter which are required for the gas gamma, the gas constant of air, I will use that. And external pressure is atmospheric pressure. So with respect to this unit system, which is in MPa, which is 0.1 MPa or 1 bar, and internal, let me say it 0.3, and we have the bursting pressure also. Anyway, I'm not putting any value over there. So that's it. So we have represented that there is there is a pressurized air inside the tank. So we have done that. This I will call it as layer. Fine. So now I can duplicate this. I can make it as front, but this I have to be careful. So I will choose front. Okay, so it's done. Yeah, so now I have created motor volumes for front and rear tanks. Yeah, now the next option is adding the mass. So if you are adding the mass on the rigid body, then there is no need to create a separate element. So in the session 1 we saw that we have an engine here and we want to represent the mass of the engine properly, because what we have meshed is just a outer shell mesh. So for that purpose we just edited the card of this rigid element, and inside that we have updated it as 200 kgs. So this is one way of you can say adding the mass, so which is quite easy and handy when you have to apply the mass on the rigid body. But other generic thing is sometimes either to balance uh, your either when you are doing the mass balancing, or when you want to achieve some of the target mass, or when you want to represent some of the entities at a particular location, and when you don't want to use rigid, of course, because that will of course differ that region, then you have to use the mass elements. So now I'm just lumping maybe a 5 kg mass on uh, this carpet region or the floor region. just to represent maybe like it's a carpet or a floor mat, that type of thing you can assume. So for that purpose, I'm going to only add mask. So here I have some options. Okay, so you have to be careful with this option. Normally we will use this add mask 1, which means like I will select some set of element or a component, and I will specify the total mass, so that mass will be distributed for that entire component. If I go with add mass 0, then the same mass will be applied on all the nodes. Okay, so that scenario is rare, or it will come only when you are applying maybe like some point masses. You can use that, but otherwise when you want to distribute, of course you have to use add mass 1 option here. So now I'm going to create this. So maybe as I told, I will want to use 5 kgs. So it is telling it is distributed type. So nodes by collector, I will choose this entire. Okay, I'm good. So I will say create. Okay, I need a collector also for this, but let me create. So I created one, since I didn't had anything here, it created an automatic collector. Okay, so this collector is also something like a collector what we create for rigid body, in the sense like it will not have any card image. So let me show you that. So if I come here, as you can see, it doesn't have any, it should not have any part definition, no property, no material. So as of now, yeah, I'm choosing it as none. So it should not ask me any property or material. It is just for the sake of to have one separate character for the mass. I'll rename it as added mass. Okay, fine. So in this section, so I did a demo on how to create a monitor volume and also how to create added mass. So this is the end of this session. In the next session, we'll be creating output request. And that is very important section, because in the case of like a full vehicle impact or any of the impact cases, we extract a lot of outputs. So you should know how to extract different types of output. So that we will discuss in the next session. Thank you.